Fundamental Resonance Episode 2, Studying the Sun from the Inside Out. An introduction to the way that data from space can be turned into sound in order to create a better understanding of the inner life of the sun. Everything really comes back to the sun. Our world literally revolves around it. It provides the energy that makes life on Earth possible. From the light and heat we feel, to the climate patterns we experience, and even the food we eat, all of it happens because of our specific position relative to the sun. The same energy that fuels our life on this planet effectively blinds us to a deeper study of the sun. The sun is essentially a massive nuclear reactor, constantly fusing hydrogen into helium in its core. It's too bright, too hot, and too intense to observe directly. We can only measure and observe what's happening at the outer layers of the sun, so figuring out what's going on inside is tough. That's where helioseismology comes in. Helioseismology is the study of the sun's interior through observations of the vibrations on its surface. Just as seismology is the study of waves that move through the earth, helioseismology is the study of waves that move through the sun. Similar to the way seismic waves move through the earth, waves of energy like acoustic waves, thermal waves, gravity waves, and mechanical waves travel through the sun's plasma. The patterns these waves of energy create on the surface of the sun enable helioseismologists to infer what's happening in the interior. To do this, they use special tools that detect different forms of light in order to study the sun's surface and atmosphere. Spacecraft gather data about its electric and magnetic fields. All this data helps scientists create images of the sun's surface, which they can analyze to understand what's happening underneath. The sun is always vibrating, expanding and contracting as it generates energy. Energy produced by the fusion of hydrogen at the sun's core travels in waves through its interior plasma, similar to the way ocean waves move through water. But here's where it gets complicated. The sun fuses 600 million tons of hydrogen every second, creating millions of identical energy patterns. These waves of energy are constantly bouncing around, refracting and changing as they pass through different layers of the sun's plasma. Though all of these waves of energy that travel through the plasma of the sun originate in its core, that is not to say they originate in a single spot. The sun fuses 600 million tons of hydrogen every second. Millions of identical reactions creating millions of identical patterns of energy, all originating in different locations. The fusion reactions in the sun's core create a series of overlapping waves, all interacting with each other, transforming and exchanging energy as they travel towards its surface. How exactly do helioseismologists make sense of all these vibrations? How do they correlate the oscillation of surface plasma to energy events happening in the interior? It is very complicated and involves a lot of math. But here's the short version. They focus on something called nodes, spots on the surface where the energy of all these different vibrations cancel each other out, leaving the surface still. By mapping vibrations between nodes, the activity within the sun, which created those vibrations, can be inferred. It's not a simple task. Philip B. Stark, a professor of statistics at UC Berkeley who specializes in inference problems and uncertainty quantification, once put it this way. Helioseismology is like trying to understand how a piano is built from the sounds it makes when you drop it down a flight of stairs, which is an appropriate transition to begin talking about the sonification of the vibrations on the surface of the sun. Sonification is the process of turning data into sound. It's a way to divine patterns within the numbers that might not emerge through the use of mathematical analysis. By using sound as a way to organize data, we can engage with the data in a new way, hearing it instead of just seeing it. Sonification provides a different lens through which to view the same information. When we listen to the sonification of the sun, we're not hearing the sun itself, but rather a sound that represents the movement of energy over time. As you listen to these sounds created from the patterns of vibrations, try to imagine what the surface of a sun corresponding to these sounds looks like. Can you hear where the waves cancel each other out, creating stillness, or where they collide, causing the sun's surface to swell? The vibrations on the sun exist in a balance between wavelength and equilibrium. The sun is a resonant sphere, a vast, vibrating globe whose surface and interior pulse with energy. Like a musical instrument, the sun vibrates at specific frequencies, with its resonances corresponding to the way plasma moves within it. The sonifications used as source material for this audio collage were created using the sonification of Solar Harmonics tool, a software package built by the Stanford Solar Center using Pure Data, an open source object-oriented programming package. If you're curious, you can check out the sonification of Solar Harmonics project at solar-center.stanford.edu/SOSH. Fundamental Resonance is a production of Fulcrum Arts. Written, narrated, and edited by Sam Rowell. Audio mastering by Sean McCann.